Today we learn basic concepts of stress and strain in civil engineering. Let's observe the picture below and answer the questions yourself. In observation, everyday stress simply calls awareness to a situation that needs attention. It reminds us to slow down, steady ourselves, focus, and get ready. We tackle these everyday stressors by studying for exams, practicing a class presentation, or thinking about how to work it out with a friend. We experience stress in daily life. Stress is a reaction to a changing, demanding environment. Properly considered, stress is really more about our capacity to handle change than it is about whether that change makes us feel good or bad. Change happens all the time, and stress is in large part what we feel when we are reacting to it. We summarize in observation stress in everywhere. Although stress is a natural part of life, when it's prolonged or extreme, it can lead to changes in physical and emotional health. Stress becomes a problem when we feel a lack of ability to control what is happening. Stress may trigger physical reactions, upsetting thoughts and emotions, or ineffective behaviors. Stress is a natural occurrence in physically, biologically, and chemically in universal process. Stress is a universal phenomenon in different fields. In this video, particularly learning applied civil engineering field, it is great application in everywhere. Also, we understanding the conditions of stress can be divided into different branches with different categories with general purposes. Let us discuss about where its root branch and sub branches under various conditions. The basically stress and strain can be divided into based on applications. The primary classification of stress and strain is physically, chemically, biologically according to study of science. It divided by the classification of stress and strain. Mechanics is a branch of the physical sciences that is concerned with the state of rest or motion of bodies that are subjected to the action of forces. In general, the subject can be divided into three branches: rigid body mechanics, deformable body mechanics, and fluid mechanics. Rigid body mechanics is essential for the design and analysis of many types of structural members, mechanical components, or electrical devices encountered in engineering. Rigid body mechanics is divided into two areas: statics and dynamics. Statics deals with the equilibrium of bodies, that is, those that are either at rest or move with a constant velocity. Whereas dynamics is concerned with the accelerated motion of bodies. We can consider statics as a special case of dynamics. in which the acceleration is zero. However, statics deserves separate treatment in engineering education since many objects are designed with the intention that they remain in equilibrium. Sir, what is equilibrium? Equilibrium is a one of condition, a state of rest or balance due to the equal action of opposite forces. The branch of mechanics concerned with the motion of bodies under the action of forces is called dynamics. The dynamics are two branches. One is kinematics, another one is kinetics. Kinematics is the branch of classical mechanics that describes the motion of points, objects, and system of groups of objects. Without reference to the cause of motion, the study of kinematics is often referred to as the geometry motion of objects are in motion all around us. Kinetics is the study of reaction rates and how they are affected. Many factors such as concentration, pressure, temperature, and enzyme activity can impact the rate of a reaction. Kinetics is focused on understanding the cause of different types of motions of an object, such as rotational motion, in which the object experiences force or torque. Kinematics explains the terms such as acceleration, velocity, and position of objects. The next category of mechanics divided by deformable body mechanics. In mechanics, any body that changes its shape and or volume while being acted upon by any kind of external force. In fluid mechanics is the study of fluid behavior at rest and in motion. Example of fluids as liquids, gases, blood and plasmas. In strength of material is one of concept to study the materials. It is a part of concept involving stress and strain in civil engineering. Strength of materials in mechanics. In the mechanics of materials, the strength of a material is its ability to withstand an applied load without failure or plastic deformation. The field of strength of materials deals with forces and deformations that result from their acting on a material. Strength of materials. Engineering discipline concerned with the ability of a material to resist mechanical forces when in use. A material's strength in a given application depends on many factors, including its resistance to deformation and cracking, and it often depends on the shape of the member being designed. What is the difference between strength of materials, mechanics of materials, and solid mechanics? The basic and main difference is in mechanics, we assume the bodies to be rigid, but in strength of materials, bodies are considered to be deformed under elastic limit or condition. Solid mechanics, also known as mechanics of solids, is the branch of continuum mechanics that studies the behavior of solid materials, especially their motion and deformation under the action of forces, temperature changes, phase changes, and other external or internal agents. Solid mechanics is a vast subject because of the wide range of solid materials available, such as steel, wood, concrete, biological materials, textiles, geological materials, and plastics. Solid mechanics is included both of the subjects, strength of materials and mechanics of materials. It is a purely related on the material science in engineering. In next class, we will discuss about fundamental concepts of stress and strain.